Hi, this lesson is about the law of sines. So again, we will be solving a triangle, but this time we'll be solving triangles that are oblique, not right triangles. So we need other techniques. So to solve a triangle, you'll be solving for all, you at the end you will know all three angles and all three sides. And in order to solve a triangle, you need at least three parts to be given, at least of which one must be a side. And then we'd be able to find the other sides and the other angles. So there are four possible cases of information that could be given. And depending on the case that's information that's given, we can either solve these oblique triangles by something called the law of sines or the law of cosines. This lesson focuses on law of sines, and the next lesson focuses on law of cosines. So we use law of sines in the first two cases, case one and case two. Case one says that if you're given two angles and one side, you will solve this with the law of sines. And case two is that if you're given two sides and the angle opposite of one of those sides, then you can solve it by the law of sines. The law of sines formula looks like either one of these two. One set is just the reciprocal of the other. So the top one says that A over sine of A equals B over sine of B equals C over sine of C. So these three fractions basically create a proportion. And if you know three parts, as I stated, you would be given three pieces of information, you'll be able to solve for the third part. And the reciprocal is also true. So using the top formulas versus the bottom formulas depends on what you're looking for. If you're solving for a side, I would use the top ones. If you're solving for an angle, I would use the bottom ones. So just to remind you of the notation, the capital letters A, B, C represent the angles. The sides are the lowercase letters A, B, C. Opposite of angle A is side A, opposite of angle B is side B, and opposite of angle C is side C. Okay, but since it's not a right triangle, C is not 90 degrees when you're talking about oblique triangles. So here we want to solve the triangle where side B is 3.07, angle A is 26 degrees, and angle C is 120 degrees. This is case one. You're given two angles and one side. And it could be any side. It doesn't have to be opposite of these angles. So the first thing I'm going to find is the third angle, because I know that the sum of the three angles must equal 280. So if I take 180 and I subtract the sum of angles A and C, you get that angle B is 34 degrees. Okay, so now we know all three angles. So now I'm ready to solve for a side. So remember, you need to set up a ratio, and right now I can set up a ratio between side B and angle B. So side B and the sine of angle B is right here, and now I can now solve for one of the other sides. So I'm going to solve for side A first. So I have A over sine of A equals 3.07 over sine of 34 degrees. Multiply both sides by the sine of 26 degrees. So you get that A is equal to this expression. And then using a calculator in degree mode, you get that side A is 2.41 units. So use the given information as your clue as to how to present the rest. So since our B is a whole number and then hundreds place, so two decimal places, you would want to present all of the sides the same way. And the same thing here, your angles are whole numbers, so this one also works out to be a whole number. And then we can solve for side C. And again, try to use this all the time in your computation along with what you computed here, rather than set up a ratio in terms of side A that could that is rounded or could even possibly be wrong if you did your calculation incorrectly. So the ratio to solve for side C is 3.07 over the sine of 34 degrees, which equals C over the sine of 120 degrees. So if I multiply both sides by sine of 120, you get that C is equal to that fraction. And so using a calculator, you get that C is 4.75 units. So a quick check to make sure you did this correctly is the angle, the smallest angle should be opposite the smallest side. Angle A is the smallest angle, that is opposite of 2.41. And similarly, the largest angle should be opposite the largest side, which is 4.75. The other two, B and angle B, that's the one in the middle. So they always have to correspond. Smallest angle corresponds to smallest side. Largest angle corresponds to largest side. Here's another example of case 1. You're given side A and these two angles B and C. So first I found angle A by adding B plus C and subtracting it from 180. So angle A is 79.5 degrees. So now I have a side A and an angle A, so I can set up a ratio. A over sine of A equals, and then solve for B right here, equals B over sine of 17.9 degrees. Again, cross multiply, move the sine of 17.9 over to the left, and you get that B is 29.1 units. So again, 1 decimal place for A, make sure your B also has 1 decimal place. And I'll again use the ratio for A and sine of A in order to solve for side C. So you have 93.1 over sine of 79.5 equals C over sine of 82.6. And again, cross multiplying, you get that side C is 94 units. So the smallest angle is angle B, and that has side B is 29.1. The largest angle is angle C, and that has a side of 94 units. So they correspond smallest to smallest, largest to largest. Case 2. So in case 2, you are given two sides and the opposite and the angle opposite of one of those sides. This case is called the ambiguous case. And the reason why it's called that is because it is possible in the case where you're given two sides and the angle opposite of them is to either find no solution to your triangle, meaning the three parts don't actually connect. So it's not a possible triangle by the given information. One answer, one triangle, or the possibility of that the given information can result in two triangles. So this one can get a little tricky. So we're going to focus on the case where I only get one answer, one triangle with three sides, three angles, and then I'll show you what the other ones would look like. So you want to solve B equal to 3.625, C equal to 2.946, and angle B, which is across from side B, is 69.37. So this is case 2. All right, so always use what's given. So we want to set up a ratio for B and sine of B, and then solve for angle C because I know side C. So here is my proportion. So in order to solve for C, angle C, I first have to isolate sine of C. So multiply both sides by 2.946. So you get sine of C is equal to 2.946 times the sine of 69.37 divided by 3.625. But remember, we're solving for C, not sine of C. So you take sine inverse of the expression on the right. This can all get put into a calculator directly the way it is. Make sure you have parentheses around the whole thing because you're taking the arc sine of the entire fraction. And you get that C is 49.52 degrees. Again, take the lead from here. This had 2 decimal places, so you want that one to be the same. Okay, but now I know angle B and angle C. We can find angle A by adding the 2 angles and subtracting it from 180. So you get that angle A is 61.11 degrees. So now that I know my angle, I can solve for side A and use this proportion here. So I have A over sine of 61.11 degrees equals 3.625 over 69.37 degrees. So if you cross multiply the sine of 61.11 over to the right, you get that A is 3.391. Here I rounded it off to 3 decimal places, just like the initial sides were given. Okay, here's another one. Solve the triangle where A is 150.5, B is 250.9, and angle C is 76.43. So this angle is opposite of side C. So I want to use that proportion, C and sine of C, in order to solve for angle A because I know side A. So that's exactly where you should start. So I have sine of A equals sine of A over 150 equals sine of 76.43 over 250.9. Multiply both sides by 150.5 and you get the next line, that the sine of A is equal to this fraction, and then you need to solve for A, so you take the sine inverse or arc sine of that fraction, and you can put this whole thing into a calculator and you get that A is 35.67 degrees. Again, C has 2 decimal places, so angle A should also. But now that I know angle A and angle C was given, I can find angle B, which is 180 minus 35.67 plus 76.43. You get that B is 67.90. But now that I know angle B, I can solve for side B and using the ratio here that's given. So you have B over the sine of 67.90 equals 250.9 over the sine of 76.43. So cross multiply. In other words, get the sine of 67.90 over to the right, and you have that B is equal to this fraction. Enter that into a calculator in degree mode, and your B is 239.9 units. Okay, so here's another one. The distance from Atlanta to Memphis and the distance from Memphis to Raleigh creates a triangle. Let A represent Atlanta. So this is Atlanta right here. Let B represent Memphis. So that's Memphis. And let C represent Raleigh. So there are my 3 cities. There's the triangle created by those 3. And the information about them is given. And by the way, this is in miles. And this is in miles. So you know that there's 640 miles from Memphis to Raleigh, and we know that there's 330 miles from Atlanta to Memphis, and the angle at Atlanta is 136 degrees. All right, so the question is to find the distance from Atlanta to Raleigh. So that's this distance right here. So in order for me to find that distance, I first need to find out what my angles are. So I need to know what angle B is. Okay, so for me to answer that question, I first need to get some other information. So first I'm going to find angle C because I can't really find angle B without finding out what angle C is. And I can find out angle C because I know what the side opposite of angle C is. So I have the sine of 136 divided by 640, this was given in the problem and you can see it in the picture, is equal to the sine of C over 330. So multiply both sides by 330. You have the sine of C is 330, sine of 136 degrees over 640. So when you compute, you get that angle C is 21 degrees. Now, since I need to know angle B so that I could set up a ratio with side B, I find angle B by taking 180 minus the sum of 136 and 21. So angle B is 23 degrees. So now that I know that angle B is 23 degrees, I can use the ratio that's given, sine of 136 over 640 equals B over sine of 23 degrees, multiply the sine of 23 over oh no, this is in the reverse. These are reversed. So I have sine of 23 degrees over B. So then you will get that B is equal to 640 times the sine of 23 degrees divided by the sine of 136 degrees, and that gives me that the distance between those two cities is 360 miles. Okay, so that ratio there should have been its reciprocal. Okay, so examples of when there's no solution, and this is why it's called the ambiguous case. If angle A is acute and the side A is less than the height, then no such angle exists. So you can see if you're given information like this, side A, side B, and the angle and angle A is acute, this is actually no way this could form a complete triangle with that height. So this would be a case of where no such triangle exists. Here's another one. If angle A is obtuse, meaning greater than 90, and side A is less than side B, or side A and side B are equal, then again, this would be an impossible scenario where you cannot create a triangle based on the information given. Then we have here another example. We want to determine the case and solve the triangle with A equal to 450, B equal to 1,260, and angle A is 64.8 degrees. So this is case 2 because I have two sides and the angle opposite of side A. So the sine of 64.8 degrees equals the sine over 450 equals the sine of B over 1260. So I get sine of B equals 1260 sine of 64.8 over 450. And if you take sine inverse and compute this into a calculator, it will give you an error. So this is an example of where this is a case where there is no solution. Another ambiguous case is the possibility of two possible solutions. So depending on how things work out, there's actually two sets of answers. So that would be if angle A is acute. So this angle is acute, meaning less than 90, and your height is less than side A, which is less than side B, then two possible triangles can exist. So I show you here that you could have a side A way out here or a side A in here, and either way it creates a triangle. Two different triangles, but nevertheless two triangles. All right, so that's it for this lesson. Give the homework a try. Good luck.